Welcome to MyMathYourMath. Subscribe if you haven't.
Infamous number systems. We got the naturals, the integers, the rationals, the reals, and the complex. All the naturals are integers. All the integers are rationals. All the rationals are reals, and all the reals are complex, but you cannot go backwards up to the other way. Excuse me for that. So, all the natural numbers are the numbers starting with 0, 0, 1, 2, 3, 4, 5, all the way to infinity. Some people start with 1 for the naturals. I begin with 0 so that we could use what's called the successor function to go from 0 to 1 and 1 to 2 and so on and so forth. The integers are all of the naturals, as you can see, but we also throw in the negatives of all the numbers. So you got negative 2, negative 1, 0, 1, 2, negative 3, negative 4, negative 5, Next up, we got the rational numbers. Rationals are anything that can be written as P over Q, written as a fraction, where P and Q are co-prime. Again, that just means they share no other factor in common other than 1. Another fancy way of saying something that is rational is it has either a finite decimal expansion, or if the decimal goes on forever, it's not random. For example, 0.33333333, that's a third. That's rational. However, pi, which is 3.14 and it's a random, infinite, ongoing decimal, pi is irrational. Therefore, pi is a real number, but not a rational number. Next up, we got the reals. The reals are really just the rationals plus all the... There's no symbol really for irrationals, so I'm going to write irrationals. So the reals are just all the rationals plus the irrationals. You get all the reals, which is all the numbers between negative infinity and positive infinity. Once we've defined the reals, we can go ahead to my favorite, the complex numbers. A complex number is a tuple. It is always written in the form of x plus iy, where x and y are in here. They're real numbers, and I is some imaginary number, and then we have a video that shows you why I squared equals negative 1. And that is all for the number systems. Quick note to mention, but not every complex is real. However, every real is complex with imaginary part equal to 0.